Hi and welcome to INSAID's Industry Immersion series. In this series, you will meet data scientists from all across the world as they come and discuss what's trending in the data science and AI space. Let's begin today's episode of Industry Immersion with yet another speaker.
A warm welcome for our next industry talks, and this is about how machine learning is used in industry. The bigger point here is not about that how many of us are very thorough with these points, but the bigger point that we need all of you to capture here is how it looks in the industry. Is it done by one person? I doubt so, because Lavi will actually elaborate on this. The system is pretty huge. There are so many components in the system. So as an individual, it's technically impossible for one to kind of carry all the operations all by himself or herself. So without any further delay, I'll hand it over to one of our staff faculties out here. And Lavi, warm welcome to you. So Lavi, you can start with a little introduction because a lot of people may not know you, especially the folks who have been trained under you, they would know you, but then we have quite a few folks who have not been trained under you. So over to you, Lavi.
Thank you, Sujit. Let me know if you all can hear my voice. All right, perfect. So very good morning to all of you. This is Lavi Nigam. So thanks a lot, Sujit, for setting up the agenda. So I am currently working as a data scientist in Gartner. So I've been in the field of machine learning for close to 6 to 7 years now. I've been teaching AI, machine learning, and all those related fields from almost 3 years now. One of the things that I come with is a huge industrial experience as to how things are done in industry. So not just the theoretical part of it, but how things are taken seriously in the industry. And my recent role in Gartner sort of helped me understand how industry as a whole struggles with a lot of things when it comes to deploying a model, productionizing a model, or how does business actually uses a model. And that's one of the things that I'll also focus a lot during our talk today. Like Suchit said, so one of the things that we'll make sure that you all understand is that it will be quite overwhelming in terms of a lot of different components that are going to be part of it, but you don't have to worry about it because like Suchit mentioned, this doesn't mean that you have to learn all of it or you have to do all of it. The only agenda for both of us is to make sure that you know that what exists, not to learn all of them all together, because it's not humanly possible for all of you to do that. But it makes sense if you understand what things are, what are new things which are part of the whole idea of machine learning and deep learning in general is. So that's a bit about me and what we're going to do today. I hope there are no questions. So just anything else you want me to talk?
No, I think that's a good start. So before we start the session, I hope all of you are aligned with the scope of the class. Please give me a quick yes if you understand that this is going to be a little overwhelming, but however, it doesn't mean you have to know everything in and out in industry. We are just showing you the overall picture. How does it look in the actual production system? How does it look as a system altogether in a company? Not one person runs a company. It's a group of people that together run a company. So don't get frightened by the terms that we'll be using. The primary essence is for all of us to understand what do these things mean at a high level. And if you're able to comprehend that, you're good enough for today's session. Okay. So let's get started. So Lavi, what I'll do is I'll ask you a few questions and possibly I know you have also given some of these pictures that you want to show. So let me start with a question here, which is around the story of modeling for every company. So can you elaborate a little bit on the story of modeling for every company?
Sure. So before I start that, can you go to the next slide and then we'll sort of come back or
would you want to kind of share your slide?
Yeah, there's just a few things.
We'll do with your slide then. But in one field, we have to be specialized, and that is what we are doing at INSAID, helping you understand that one particular field, which is either data science or machine learning or AI. Okay, or you could possibly run data science, machine learning, and AI, all three. But however, I'll leave it to Lavi to kind of take it over now.
All right. So basically, the very first question is the story of modeling for every company, and that's framed very aptly because a lot of you might not understand that when we say something like modeling, what do we actually mean by that? In a sense that you do understand that we have to do modeling and all, but what you might not understand is that the whole life cycle of the model is slightly different for each companies, and specifically companies which are sort of doing any kind of production pushes or consumer-centric applications where they have to put their models in front of the consumer. Now, I have a very beautiful diagram to explain that, and this is sort of taken from one of the very interesting papers coming out of Google, which is Technical Debt of Machine Learning. If you have not read it, please just Google it out. It's called Technical Debt of Machine Learning by Google. Now, one of the very interesting thing that there's a diagram that sort of talks about the fact that if you see the whole process of the machine learning and not just the model, you will one thing that you will note is that the ML code, specifically where you have just the modeling part, is a very small code of it. If you see the other buckets of it, so we'll start with configuration automation. Now, what it means is that it's not just the fact that you have to do configuration, but the fact that for you to do a whole complete setup, there is a lot of configuration that has to be part of that. Now, similarly, data collection, data verification, feature engineering, I think all of you are aware of, and you know what these things are to a certain extent. So these are those components which you know. ML code is something which you again know because you've been doing machine learning to a certain extent. You know how to sort of do machine learning over it. Now, if you go to the next component, which is testing and debugging, now this is where a lot of things we have never done. So for example, we have never talked about how do we do a testing or a debugging of our model. Like, do we know whether our model fails in a specific scenario? Do we do any kind of quality assurance to our models? Like if they are going to go in the consumer centric viewpoint, where our models are going to go, haywire. And this is what the testing debugging phase, which most of us don't really focus on. So that's another kind of things which are, as a company, people would want to focus on this. The next is the resource management. Resource management actually talks about the fact that if you have a modeling exercises of if you have a model that you're trying to build, you need a cloud infrastructure or infrastructure that you can sort of deploy your models into, so that again a customer centric or business centric users can sort of see that thing, right? So this is what another viewpoint that you should be aware of, that what is the resource requirement. I'll give you a very quick view of that. See, for example, let's say you're working on 1 GB worth of data. Now, once you do that 1 GB worth of data working scenario, you also have to be aware of what is the resource requirement you would have in order for you to do two things specifically. One, that how much RAM, how much machines, what kind of machines would you require to do the modeling. The second is, once you do the deployment of such models, what is the backend requirement of those servers that you're going to be useful for, right? So these are two things which again comes under the resource management. Then comes the model analysis. Now, model analysis is a very important and a very overlooked area of machine learning, which again, a lot of bigger companies have started doing. And I'll give you a very good view of it. A lot of students who have gone through my classes, they have already seen the kind of model analysis we do in the end to end. But however, for most of you, model analysis means that how do you basically analyze post modeling? So for example, you have done, let's say 10 models, 20 models, different hyperparameter tunings and bunch of those things. Now you need to, just like you did the EDA on the data, you do a very similar EDA on your models, which is to say that you try to understand, rank them, you try to understand their behaviors, how are they behaving with different cross validations, how are they behaving with different set of data, how the time constraints are there, how the complexity in terms of resources there. So maybe some models are taking more resource to do a prediction, and there are some models which are not taking that much resource to do a prediction. And these are slightly things which you have to be very focused on. And that's what we mean by model analysis. Now, moving to process management. Process management is again, when you have so many pieces on the infrastructure which are sort of talking to each other and they are going hand in hand on each other, you need a management which can connect all of these together. Now, one of the areas in the software world, we call this as a DevOps, is slightly doing the same thing, wherein you have a connection between different kinds of components working together and then doing a production push, which is what also needs to happen in the data science, which has started happening. And I'll talk about certain of those tools. Then we go to metadata management. Again, this is something which is slightly related to the fact that, see, again, let me give you a scenario. Let's say you're working on a GB worth of data and you have to do like thousands of models over it, because obviously if you have to do something at a production level, you just can't build one or two models. And thousand is an overkill word, but I'm just giving you a view that you would have to do multiple models. Now, at that point, it becomes crucially important that you need to make sure that your models metadata, so whether you're saving a model, all different models and their metrics, and your different variations of your data that has been changed. Now, one of the quick way to understand this is the same code management that you do on GitHub or any Git related things where you're managing the versioning of your data code is very similar to managing a version of your data as well as the version of your models, which we'll again go in detail and talk about. Then we have serving infrastructure. Serving infrastructure essentially means that once you have a model deployed, what is the infrastructure that is going to be required out of it, which is again in connection with the resource management. And then the last one, which is the most important, and that's why it's towards the end, which is the monitoring. See, it's like this. Again, I'll give you a view of it. Let's say you do a model and it has been pushed into production. Now think about it for a moment. Do you all agree that this model at any point of time might stop giving you results which may or may not be accurate, because all that you have built is on the historical data. You don't know whether it is going to give you a correct prediction or not until you have a business reporting back to you saying that, hey, our businesses are flowing good, we are all good on your model. And this is why you need to do the monitoring of your models constantly. And there are a lot of technical ways of doing it. There are a lot of things which people and data scientists have started doing it. But this is what, the whole world of just like the very the very beautiful way of putting this is the story of modeling that some of the companies are doing and some of the companies would want to do that. And this is why these two distinctions are important to know. It is not to say that every company does that, but what is more important is that there are some companies, specifically the ones which are internet companies, so your Google, your Microsoft of the world, your Apples, and all of these bigger ones, they are doing it. Then there are a lot of other companies which are trying to catch up to these world, and which is why we are having sessions like this, because we want you to be aware of these things. Not that you need to learn all of this, but you need to learn the story in a more comprehensive way. Okay, so that's what we mean by the story of modeling from every company. So over to you, Suchit. I think that's
awesome. So I think, yeah, we talked a lot of things, and few important aspects here, friends, to kind of note down is a pre-machine learning, within machine learning, and a post-machine learning era. So pre, you do certain activities. During machine learning, you do certain activities, and post-machine learning, you do certain activities. Even within these activities, you can again subdivide them into respective kind of components, which are handled by different teams altogether. So please don't get bogged down if these things look really big to all of you right now. That's only because these are not done by one person. So thank you, Lavi, for this information. Coming down to the next question is, how do you kind of make the models useful in production? A model, if I understand correctly, Lavi, it's just an equation that we figure out from our data.
right.
How do I use this equation in real world?
So, and that's a very interesting question, because a lot of people have this misconception that, if you have a model, that model is something that can give you an inference or a prediction, but then we don't know how to put that in production. And what do we mean by production to start with, right? And here's an easy way to think about it, which is to sort of say that just like you have exe files, think of it like every application that you have on your system, they're also code which somebody has written, and they have written a lot of logics inside it. And then they package all of them together in a .exe format, and then they give it to you. Or if it is Mac, it is in a .pkg format. But essentially, that's the whole idea, that they package all of them together into a specific extension, give it to you, and then you just click on it, and then the whole setup happens. And the whole unzipping and setting up of that happens on your system. Very similar thing happens on machine learning, which is to say that when you actually have a machine, sorry. So very easily, what we have to sort of think in terms of machine learning is that once you're done with your model, so you are not sure that this is the model that you have to do. This is what we are doing currently. So the architecture that you see here is something which is currently being taken care. So once you have trained the model, you create a model serving, which is like you package the whole model into some extension. It's like a single package, and then this extension goes on to the internet, and then there is an API that gets created out of those packages. Now, for those of you who don't understand API, it's very simple. It's like there is an interface which is available for you to do a query to that model. Just like you have SQL query, just like you have any other query that you do on the internet. So now what happens is you have a internet hosted or a local hosted interface of your model, in which if you throw the data, so your throwing of the data could be, all rows together or single rows one at a time. And I'm going to show you a demo today, so it will be slightly clear to you that what do I mean by APIs, what do I mean by interfaces of the model. But this is what the whole story of production is, that you take your model, package it into a extension, that extension goes into the internet, then it has a address that you can access. Once you access that address, so it could be any IP with that thing, and then you throw your data to that, and you'll be able to query the prediction back. So just like you used to do dot predict in your scikit-learn, imagine you're now able to do the same thing on the internet. So that's a very easy way of understanding the process of production. Now, once we understand this, once we understand this basic manual process, the next thing we need to understand is how does this process sort of goes, in the world of MLOps. So again, there's a word called MLOps, and all of you should know, at least so that you understand that what is it you need to look for. You don't have to be an expert. You don't have to learn it. You just need to know that there is something like this exists. So MLOps means operational machine learning or machine learning operationalization, which is to say that if I have to do this thing, see, for example, again, think for a moment. If you have to package a model and put it on the internet for somebody to query and get the prediction, at the very same time, you would also think that there is so much of operational things that you would have to take care of it, right? Which is to say, how soon are you going to push new model versions of the package? So currently you have, let's say today you worked on a model, you push this version that is sitting on the internet. Now, once it is sitting on the internet, maybe after 5 days, you have another new one, new model version that is coming up, which is what you take care through ML ops kind of scenarios. ML ops is a theoretical setup wherein you have a lot of tools and things like that. So if you see this diagram, this is, what sort of defines that from an industry point of view, from an enterprise point of view, how do we take care of the same cycle that you saw here, which is most of you are aware of the cycle, except the last two one, which is the model serving and the model service, which is where I said that it has the interface on the internet for you to query that. But it goes slightly more comprehensive when you see the enterprise version of it, which is to say that you have pipelines which are built. You don't just do notebook driven analysis. I mean, there is a part of notebook driven analysis, but then you go in details of doing it from the point of view that you have, you have to do all of these in an automated way. Now, a lot of you would be hearing things like auto ML and things like that. And this is where, it's quite important for you to understand that auto ML doesn't mean that your job is finished, that you don't have to work on anything. Just like any other tool, it is just for you to augment your day-to-day work of what machine learning has to do. Because see, now this is why I started with this diagram, because first, when you understand that there are a lot of loose ends that you have to understand in a whole process, that is when you'll start appreciating the auto ML part in the whole pipeline, because you will say that, hey, if I have to manage so many things, if I have to think about so many things, wouldn't that be much easier that if I have an automation on specific parts of those tools so that I can then combine them together to produce something better? So this is what we do from the enterprise level, that when you have the enterprise setup, the architecture looks slightly different, where you do many automations of individual steps. You don't then do manual things. You don't see, and this is one of the things, and we won't be able to sort of completely cover this in this sort of short session, but you should know this, that the way you do machine learning and data science right now on the notebook is slightly different from how enterprise take it. Not to say that they don't do the notebook end to end, they still do that, but there are a lot many components associated with it, wherein a lot of other people across the teams are collaborating. And this is why I wanted to sort of all of you to see this kind of a diagram, wherein you know that, for example, there is a team which is focusing on the pipelines of the initial data validation, initial model validation. Then there's a team that is focusing on the feature store, where they're storing all the features which people are sort of working on. Then there is a team which is typically nowadays called ML engineer teams, which are sort of focusing on combining all of these things into, in a singular pipeline that can be automated. Similarly, which is what you have, the ML engineering teams or the engineering teams are taking care of the deployment part of it, the serving part of it, and so on and so forth. So this is all the different, smaller components which are sort of going here and there, and a lot of people in the teams are sort of collaborating and creating an end-to-end system. So again, just like Suchit said, and I agree to that point, because this is one of the issues in the industry, that when people hear different things about ML, they think that they have to learn everything. It's not that. You have to be an expert of a certain area, and not that I can tell you right away that, hey, please just learn this. The fact is, once you're now aware of these are different components, now you have to see what is your skill set, what is that you're good at, and how can you develop those skills, and be good at one thing. Don't try to be jack of all trades, because that never works, and companies don't work like that. It's not, you'll not see one person working on machine learning in any company. Google has like 300 people working on a single feature. So imagine if Google can afford to have 300 people for a given application, which is an AI driven application, then we are not at a level of what 300 PhDs can do together, right? So that's what we have, in terms of pipeline. I hope that makes sense. Any questions on that?
So, Lavi, questions are in plenty. I think a lot of folks out here have started panicking. But yeah, so friends, don't worry. See, the point of doing this session is because I have seen a lot of people being really interested on the bigger picture. A lot of people keep asking me, Suchit, okay, how do I now put this to production? The point is, in production, enterprise level production, they don't work on small things. They work on a lot of small things. Okay, they just don't work on one small thing. Machine learning is just one small part. If you remember what Lavi had answered in the first question, machine learning is just one very small, fine component of that entire story. It's a very small part. And there's this whole ecosystem around it that needs to be built. Okay. This in itself has so many different types of jobs. This in itself will give you some at least 5 to 6 different varieties of jobs that you can think of. Now, coming to the next diagram, Lavi. So if you just scroll down to the bigger picture of enterprise version, you see each of these are actually possibly a role in companies. In really big companies, a lot of these actually end up being different roles. A part of it is run by data engineers. Okay, a part of it is run by data scientists. A part of it is run by some database team. A part of it is run by the DevOps team. This is run by DevOps team. CI/CD, continuous integration and deployment. These are run by DevOps teams. If you guys have heard of tools such as Jenkins, SPM, SVC, okay, these are all tools that help you automate these entire things. Now, how many things will one person learn? Okay,
Right.
so
Yeah.
let's be clear about that. There are too many tools out there. One person cannot learn everything under the sun. So this is a very high level overview of what happens in real world at scale. Okay. So what we'll now discuss next. Okay. So don't hold on to your questions. If you have some questions which are really bothering you right now, hold on to those questions. We'll take some time towards the end. Lavi has a small demo for all of you. So we just want to get to the demo so that we can see the bigger picture. So
Yeah,
Lavi,
I think I think that's a better way. But before I go there, let's just quickly talk about, because I think some of them are asking about
the
what are
tools.
specific tools that we
Yeah.
have. So
Right.
I
Right.
have a very beautiful slide where we have like the names of those, so you can take a screenshot and sort of talk about it. But here's at a very high level, these are the tools, and I'm going to show you a demo where some of those tools are sort of used. Okay. So when we talk about data and ML pipelines, and when I say data and ML pipeline, so for example, again, just quickly think that when you do a EDA, or when you do any hyperparameter tuning of multiple models, when you go to the production, you can't do this manually. You need to have an automated way where these things can be taken care automatically. So these are certain tools. So for example, you have Kubeflows, you have Pachyderm, which is there. You have Algorithmia API, which is there. You have Apache Airflow, which is there. which sort of helps you connect all of these pipelines together and run. Then you have something called as data versioning. And I think I did remember talking about that. You need to version your data as well as you need to version your model, just like you version your code. So in that regard, there's one which is very common and very widely used, which is called as DVC. DVC is just like GitHub for data science. For those of you who would like to explore, just search DVC on the internet and you'll get to see what it is. Then on third, you have experiment management, which is ML Flow. ML Flow is by the people who have built Spark. So what ML Flow does it sort of gives you a whole dashboard of tracking everything into a single dashboard. Like for example, how many different kinds of versions of data you created, how many different kinds of models have you created. Sort of it gives you a dashboard to look into it. So rather than having a view of notebook, you'll then have a view of a dashboard. So these are certain tools which are widely used. Along with it, there's something which is very important, which is called as Docker. Now, here's an easy way to understand Docker. See, when you do something on a system, like on your system, and if you have to deploy this on the internet, you would have to do the whole setup of whatever you have done at your end, right? So if you have done a setup of, let's say, some libraries, some basic things, you have to do the same setup on the other end as well. Now, in that regards, Docker basically helps you save that. So let me now go to the demo that I have planned for all of you. So in this demo, what I'm going to show you is that I basically have image classification algorithm, which sort of uses a deep learning model to do a classification of different varieties of dogs. So my goal is I want to show you that how we go from modeling to production. In production, how do we deploy it? And how do we send the data to this API that we have talked about initially, right? So for example, when I said that now I'm going to host something to a link, and then I'm going to throw an image to it, and I'm going to expect that it should return back the predictions out of it, right? So which is to say that what we are doing in this case is I have a model that I've built, which is a ResNet model. Again, for those of you who don't know what these are all deep learning models. Once I have these models, what I'm going to do is I'm going to create a web server around it. So all these files that you see here has a requirement.txt, wherein I have mentioned that these are the important libraries that I need. And then I also have, I also have some of the other libraries that are required. Now, this particular demo has a infrastructure. So let me actually talk about what this is going to do. So what this basically does is, this is basically ML API. So if you have ML API, we need certain component. We need a component called fast API, which sort of helps us create the API out of a model. Then we are going to use something called as Docker. Docker is going to help us do the deployment of whatever we have created onto the servers directly. So you don't have to do resetup of everything. So let me show you how that actually works. So, so what you see here, in fact, let me date clear. Yes, this API is made using, there's a lot of components in this, but the one that you should be aware of is Fast API. Yes, it's a reusable library. So let me just stop the server. So you can see that currently what I'm showing you is I'm at the folder where all these codes that I was showing you is there. Now, the way to deploy this is very simple. I'm just going to hit one line, which is called as Docker Compose. You don't have to worry about what these words are, but just see the kind of potential it has. Like I'm just gonna run this line, and do you see that my server is up and running? Now, what do I mean by my server is up and running? Now I'm gonna go to my other window and I'm gonna do something which is very interesting. So let's say I go to the internet and I just search for dog images, and let's say, yes, so I am deploying it on my local server because I can't show you something on the AWS or something as of now. But let's just say I have a dog which is, let's say, German Shepherd, right? So I take a German Shepherd image. I say that save this image into my folder, and I'm going to call this as doc5. So doc5 is now saved. Now what I'm going to do, and I'm really sorry for if the kind of things that looks really awful, because things are all in command prompts, but this is the nature of these things, right? So please don't get overwhelmed, but it's just that this is how things look like when you actually do production. So see, what I'm essentially doing is I have a API which is hosted on the local host, which is what my local server is. To that API, and this is what I said. See, currently because it is hosted on my local, the problem is that I don't have the IP of the remote server, but you can very well set this up into your AWS or any of those things. And then we are sort of using that local host IP, which is my local, and I'm now sending doc5 image, which is what I've just saved here. So if you see, doc5 is the image that I've saved. Now, what is my goal is I have trained a model and I'm going to show you how live I can interact with the model. So I'm sending this dog5.jpg, which is the model that I have. And now I'm just going to call. So you see that I've just hit the enter. And it gives me the prediction. So now if you actually see the prediction of it, do you see what the prediction it says? So the first label it has prediction is German Shepherd. Probability is 99%. Now see how easy it is to do that. And I've just shown you that, this is something which I'm doing. It's not a model where I'm using the same thing. In fact, let's do something else. So let's say we have a white dog and we don't know what, I think this should be husky. Let's see, let's call dog husky. Now let's save this as a model file. So I'm going to query this now. So we'll say this is dog6. Now I'm going to do the same thing. I'm going to send my dog6 image and let's see what this model tells us. So this is basically, again, see, it's great. So it basically figured out this is a Siberian husky. However, it is not very confident, and it sort of gives us 59. Now here's another suggestion with somebody saying that let's send this as a cat image, right? So I'm going to send you, let's try this out. I'm not sure if this works, but what this should do is it should give us a very low probability. So let's say we have cat, just the last one I'm going to try. So it basically gives us the cat image as well, right? Because just like I said, so this model is trained to figure out different kinds of cats and dogs, and it's trained to do that. Now, if you see the back end of my model, it sort of tells me that how many times somebody is trying to hit my server, and this is the server which is running. So you see how easy it is, how easy it is to tell and deploy models. Easy in a sense that I'm not saying that, the whole setup of what I have done was easy, but I'm just saying that this is what it means by production. Now, imagine that these kinds of APIs are integrated in a product, which is what companies are doing machine learning for at the end of the day. So for example, if you're taking a photo and you want to convert that photo and predict a face of a person, this is exactly what is happening at the backend, that the photo is going back to the server. The server is then predicting the kind of a bounding box that needs to be predicted, sends back, and then you sort of see the output of it, right? So this is what we mean by model production. So what I want all of you to understand is that when I say model production, or when people say model production, this is exactly what they mean, that they have hosted the model onto a remote server or a local server, and you can now throw your data at it and get the outputs, which you can then use to do your analysis of whatever it is that you have to do. Now, once we are done with it, this is why, if I go back to the discussions that we were doing, that why do you have so many components that people have to take care? Because when you do production, just like you do production in software engineering, there are thousands of things that you have to keep in mind. But do remember, not all of this is done by a single person. Not all of this is taken care and learned by a single person. You just need to learn how to do things one at a time and be aware that these things exist. Okay, over to you, Suchit.
Okay, very nice demo, Lavi. So Lavi, before we move on to the next few questions, let's say, can you kind of spend some time to talk, what did we not discuss today? Because to be very honest, this space is infinite. And to be very honest, most of the folks are still struggling with how do you do this, how do you do that. The point is, friends, please understand this is years of work. What possibly makes sense for Lavi or what possibly makes sense for me, that's because we have been in the system for years.
Right.
It's not something that you can learn in 10 minutes, but we are trying to show you the bigger picture here. So don't lay your focus on the smaller details. What is a curl? How do I do a curl? What is a API? These are things that you got to learn first before you even talk about these things. So Lavi, there are possibly infinite things that we have not covered. Can you just talk about a few of them?
Sure. So this is what the overall things that we were not we have not talked about. But again, because we have seen that there are a lot of things that we are talking, so I'll restrict to ones which are very important, keeping in mind the next 5 years of ML. So here's my idea. I want to talk about certain topics which are going to be important for next 5 years of the industry. Just like Suchit said, see, you have to also understand that this is not like you have to just learn everything and the next month you have to just deploy and then that's what is going to happen anyway. Because of the coronavirus, the whole industry has slowed down. So it's like everything is going to be very slowed now. So which is to say, this is, think of this as next 5 year plan kind of a thing. Like for example, first learn the machine learning which you all are learning, then now keep your 5 year plans according to the discussion that we had today. Okay, now going ahead, the first thing which is very important is the explanation part, which is also called as model interpretability. Now, again, for those of you who have studied with me, they know this very well, that there are applications like SHAP, and I'm just giving a name of it so that you can just do a Google search of it. There are two bigger applications, which is called as SHAP and LE5, which simply means that, see, for example, just like Suchit said initially, that all models are nothing but y equals to fx, right? If they are y equals to fx, y equals to fx might make sense to either a data scientist or to a mathematical guy, because he understands y equals to fx. But if you go in the business world, they don't know what these things are. They don't care whether you have done a complicated model or an easy model. What they care is, for example, if you are saying that this guy is a fraud through your model, the business wants to know, why are you saying that? Tell me exactly the reasons why you're saying this guy is a fraud. They don't care whether you have done XGBoost, whether you have done Light GBM or any of the model. This is why model explanation or model interpretability comes into effect, wherein there are many packages nowadays which sort of helps you do that. So SHAP is one of them which you have to Google out and think about. So that's one. The second is privacy preserving ML. Now, this is very easy to understand because here's another way to think about it. Now, imagine that, nowadays there's a whole talk about privacy in general. So for example, when you send your data to any servers, whether you're sending it to Google, Apple, or any of these companies, do you agree that you would also want Google to not use your data? And that is where we are going as a whole world, right? We are making sure that not our data should not be used by any of these companies. And this is why the problem with machine learning is that it works very well as long as you have a data which is not encrypted. Now, what is happening is, I'm not sure if you know this or not, if you use Apple or Google, or if you use things like WhatsApp, all your conversations are encrypted and stored in server. Now think for a moment, if it is encrypted and stored, what will you do in order to do machine learning over it? Because if you have to do a prediction of, let's say, next word, how do you do the prediction of next word if you don't know what the actual word was? Because it is completely encrypted and stored. This is why this whole world of privacy preserving ML is coming into picture, wherein what companies have started thinking about and what different new packages have been emerging out of it is, how do you do machine learning over encrypted data, that you don't do the decryption of the data, because consumers are not going to give you data right like this, so they will be sending you encrypted data. How do you do machine learning and deep learning over encrypted data? Again, this is going to be very important moving ahead in the 5 year horizon, that you need to learn how to do machine learning, because so often you have all been working on data which is not encrypted, and that's not going to happen in the next couple of years, right? So that's what is the other topic. Model and data versioning I've already talked about. There's another thing which is called as adversarial robustness. This is what the model testing part of things are. So when you have model, so I talked about at the very early stage that there's something called as testing in the modeling. So model testing in QA happens through something called as adversarial robustness, which is to say that how can we create practices of testing in QA when it comes to model? Can I create adversarial examples? So can I make examples that will fail my model? Just like when I was actually showing you the example of the demo, some of you were actually saying, hey, Lavi, can you send a cat image and see whether your model works? See how good our brains work in order for us to create adversarial examples, because we know, we know that where things might fail. Now, just take this use case and think that if that is what you are able to think by just seeing a model, isn't that a practice that has to be developed at some point where people should be able to do testing and create adversarial ways of doing it? Now, at the same time, where you have to see where the model fails, it then becomes a duty of machine learning / data scientist guy to take care of robustness with respect to adversarial data. So that's another thing which is sort of, which is sort of very important. Then you have neural architecture search, which is what AutoML and AutoDL kind of things are. So things like Teapot, things like Ludwig. If you have not heard about what Ludwig is, just do a Google search. And there are many others, but I'm gonna just stop here because you have the list, so you can just go and Google it out. You should be able to learn about. But these are the ones which I really wanted to talk about because these are the most important from the next 5 years point of view. All right. So yeah, Sujit, I think the others, they can just Google it out.
Okay, very nice. So a lot of you might be wondering, okay, there were like bouncers after bouncers. So the question is, how do I refer back to the material? Friends, don't worry, we'll post it on your LMSs as well. You'll get it in your respective LMSs as well. But again, I'll repeat, do you really need to learn everything under the sun? No. These are done by multiple people, different people do different things. As you move up the ladder in your career, you might start noticing more broader things. Okay, so it's not that you have to do everything day one. So that is what we wanted to kind of discuss today. I know it would be a bouncer for a lot of you, but that's totally okay. This session was meant for you to see the overall picture, and overall picture is not something that everybody can digest right away. So what we'll do now is we'll open up Q&As. However, we'll take selected question and answers. We're not going to take every question answer because I've seen people asking, where does Spacey come in here? Okay. The point of Spacey is not a discussion point here. It's just one more package for natural language processing. Okay. It has nothing to do with the way we deploy machine learning. Okay. It's just a library. So if you have ever heard of that word Spacey, first go and Google what is it. Instead of asking where does Spacey fit in infrastructure of machine learning, doesn't work that way. See what is Spacey? It's just a package. Now the good thing that I would like all of you to understand is we'll do a small live, I would say, Lavi, can you just unshare the screen for 5 minutes? Yeah, so we'll do a small live demonstration, and what I need all of you to focus here is what Lavi has shown here. I will show you the same thing in a different form. And this is a form that all of you can digest to a great extent. Okay, so I hope all of you know this website. Yes, friends. If you guys don't know, this is a website where you can check out the prices for your used car. If you plan to sell your used car, this is a great website to go ahead and sell your used car. So this will give you a fair price as to what should your car be priced at. For a customer like me, am I really interested to see the screens that Lavi had shown us? Those black and white screens? No. For a customer, this is what I need to see. But what is this? This is called as the front end, the websites. Okay. This is in my local computer. I can see this picture. Now I select, I want Honda. I want to sell my Honda car. My Honda City. Okay. I want to sell the 2016 year model, the VX empty petrol model. I stay in UP. I selected all the inputs for my machine learning to predict the output. Okay, I'm passing these inputs to the machine so that the machine can send me the output, which is the price of your car. What should the ideal price of your car be? So I finally put some number here, and then I ask, show me the price. obviously they are not asking Dhoni, they are asking the machine. The machine is going to come up with this answer that your car could be priced between 7.88 lakhs to 8.48 lakhs. What happened here, friends, is you just saw one layer in operation. You're just seeing the front end, which is in your computer. In your computer screen, you're able to see this website running. But what you didn't see was there was a request that this computer made to Lavi's server or Car24 server, and they processed all of these information. What was your car? What is the type of the car? ... They passed all of these details to the machine learning model. Okay, the machine learning model, it sent out the data to this model. The model realized that the price of this car should be anywhere between 7.88 lakhs to 8.48 lakhs. Now, what you saw on Lavi's screen was exactly that this is a type of this XYZ dog, and this is the probability of it. But do you show this to the end user? Do you show this is the probability, this is the dog, it should ideally be? No, you don't show these things. A user is least bothered about this. So you beautify, you get this data from the back end, okay, and before you show it to the user, you beautify it. You make it nice and very helpful for the user to understand that, you know what, if your car is in good condition, it is priced at this point, which is in this range, 7.88 to 8.48. So you see, what Lavi showed you was the entire back end of it. Now, running the back end for this size of a company, Cars24, how many cars are they handling? How many cars do you think these guys are handling every day? Thousands of them, possibly lakhs of them. Okay, people are querying. See, it doesn't matter you're buying or not. I am querying, right? Like me, another hundreds of you might actually go ahead and query. What is happening to the server behind the scene? The server has to be able to take that load. Think about it, Flipkart. In regular days, thousands of people shop on Flipkart. On big billion day, what happens? Millions of people start shopping. The server should be able to handle that kind of load. Server is just one more computer. When you start working on your computer, you open one VLC, one Excel sheet, one Word doc, one XYZ, one Google Chrome. When you start opening too many applications, is your server able to respond? Is your computer able to respond properly? No. As the load increases, computers also have to increase in size. So the servers have to start increasing in size. That is called as auto scaling. Okay, so behind the scenes, Cars24 has to keep scaling and descaling continuously to handle this kind of pressure from front end. This is just my computer. The screen that you're seeing, it is from my computer. Likewise, if all of you start bombarding this server continuously for your car price, there could be millions of hits in 1 second. Yeah, Policy Bazaar, any website, millions of hits in 1 second. Behind the scene, the computer has to auto scale, auto descale. The computer has to run the machine learning algorithm, run through this data, give the output, take it, send it back. So many things are done. Is it done only by one team member, one particular component in the machine learning field? No, it's a huge ecosystem. So the ecosystem is what Lavi showed you today, but what he showed in the demo was how it runs in the behind, the back end. In the back end, it looks like that. However, when you are going to see in the front end, this is the beautiful output that you're seeing. Okay, same in Uber car price. When you just log into Uber and you're saying, I want to go from A to B, they say that it'll cost you 321 rupees. This is something that I'm interested to understand. I'm not interested to understand that behind the scene, the model has given me 50 such numbers. Okay, the first one is called as the effective pricing, the perfect pricing, the roundabout pricing, the probability of the pricing, the range of the pricing. I don't want to see all of those things. I just want to see rupees 321 as a customer. So behind the scene, whatever you're seeing here is majorly for the data science and the machine learning engineer at work. However, for front end, what is important is, can I convert that complex language to simple language? Now I'll take one more step back. Few folks have doubts, what is a model? Think of this. If the price of my car, so as Lavi said, y is equal to fx is basically a model. It's basically a math equation. To be very simple, what are they saying? Price of the car. So if my price of the car is dependent on, say, 5 times the kilometers, the years of how much years old is my car. So years plus say 1.2. So 5 times the number of years plus minus. Oh, my equation is wrong. Price is equal to say inverse of years. So say 2 into 1 by years plus say 7. Now the question is, if my car is 1 year old, what should the price be? So the front end, the customer has sent to the server that my car is 1 year old. So what should the price of the car be? It should be 9 lakhs. Okay. You divide 1 by 2, or sorry, 1 by 1. So instead of years, you pass it as 1. So 1 by 1 becomes 1. So 2 plus 7 is how much? 2 plus 7 is 8. Just replace this equation, y is equal to fx. Okay, instead of years, you pass this 1. If it is 2, then what is the price of your car? So this is for a 1 year old car. For a 2 year old car, how much is it? It is 8. Okay, so 1 by 2 into 2. So it's basically 1 plus 7, which is 8. This is for 2 year old car. For 3 year old car, it'll be 7.66. Okay, and dot, dot, dot. So point is, this will keep decreasing as the number of years your car has been in existence. So I just showed you one parameter in the machine learning model where, with respect to the years of that car being with you, how is the price varying? And the model has figured out this equation. So from front end, I just told my car is 7 years old. You passed it to the model calculated the value. It stood out to be say 7.21 lakhs. It sent it back to my front end, and in front end, I saw that the price is 7.21 lakhs. It looks very simple on the outside. However, friends, behind, if you see, this is a big ecosystem. This in itself is what we are trying to grab hold of, how to make machines learn. Is this the right time to learn how to make production level servers? Maybe not. But as long as you have seen and you know what it looks like, I think that is good for all of you to kind of just touch base on. Slowly, you want to kind of explore further things in the space of machine learning. Take time, take space, don't rush into things. We have learned it over years altogether. Don't try to learn it overnight. Okay? It takes days and possibly months and years. That's what every person out there, what Lavi talked about, those 300 PhD folks, they have spent years altogether to build such things. We can't do it overnight. So let's not get there. Okay, so I'll open up for a few question and answers, friends. But however, be mindful, we are not going to answer any queries. That is, what is AWS, what is GCP, anything that we feel is not something that should be answered here. We'll not be picking it up. So don't feel bad if that's the case. We are just going to be practical out here. So how is the job market will accept me as a new entrant? Okay, again, this is not about you, Mayank. Repeatedly, I'll say this session is about data science, machine learning in production. Let's focus to questions like that. Okay, for a person from data management background, and okay, again, we are not taking for a person questions. How is ML model packaged as a WAR file? So Suprakash, what you have to understand here is WAR, I think you're talking from Java perspective. So every coding language has a way to package their products. In this case, what we do is we create microservices. If you have seen Dockers, what Lavi had shown, Dockers literally serves the microservice purpose. It makes it as a microservice. You can just hit that Docker to run the machine learning model. It'll fetch you the output. Can the machine be trained to auto-optimize the model that is fed to the machine? Lavi, would you want to take up this question?
Sure. Yes, it can, but you would have to write a very detailed pipeline, and you would have to use tools like network architecture search and things like that. It's possible, but it's not something that you can do right now. It takes a lot of time and a lot of effort to achieve that.
Yeah. So Soumyajit, what you might want to also check up is H2O. So H2O has something called as headless AI. Just check up what does that system do. What are the parentheses that are considered for sizing servers? Vishwanathan, if you come from infrastructure background, you would already know what is the parameter to do sizing of servers. It depends on the load. It depends on how many hits you're going to get. It depends on what is the transaction that you're doing between the servers. There are tons of them. Okay, so see, machine learning deployment is no different from some other software deployment. If you guys are under the assumption that machine learning has a whole new way of working, no, it's just a software. At the end of the day, the way you have installed some other production system, machine learning also works the same way. Rest of the components are all same. It's just only the machine learning part that is going to be different. So don't mistakenly think that machine learning production is very different from real world production. Real world production, machine learning production are all the same. It's just a software. can someone deploy pricing model the same being used in quicker, or will everyone build their model? Everyone will build their model. Okay, Raghav has asked some question. I couldn't totally understand that question, Raghav, but let me kind of rephrase it. So Lavi, if I want to make my own Google search, okay, is it possible? Or should I wait for Google to open source their search?
It's possible, not to the scale of what Google can do, because they do collect a lot of data. But I think what he might be asking is, can we do something like enterprise search, which is more intelligent than just searching? So yes, it's possible. There are many open source. So there's something called as Elasticsearch. He might want to sort of just Google search it. There are ways in which Elasticsearch can be integrated with NLP, ML models, and DL models, and that way he can sort of do a very intelligent search.
Absolutely. So what you'll find is you'll find a lot of open source models, but that, however, does not mean that it'll solve your purpose. There's nothing called as one t-shirt that fits all or one size fit all. There's nothing like that. You might find a t-shirt that you can cut and stitch and make it fit to your body. So in the same sense, you might find models which are open source, which you need to cut out and tweak to fit your business criteria. But however, for every business, you need to make your own models. First of all, Cast24 will never give out its data to you. Why are these companies so successful? Because they have their own data. They don't rely on somebody else's data. They have collected a lot of data, and this is their, I would say, this is their wealth. Think of it, the amount of money in your bank is your wealth. For Google, the amount of data they hold is their wealth, because everybody is now dependent on Google. So every company wants to build their own data on their own data sets. So as much as possible, try to capture as many data points that you have in your company, and then possibly build algos or solutions around it. We just have another 2-3 minutes, so I'll just see which all questions we can take. Lavi, if you have any interesting question, do let me know.
I think I see one which I think Raj has posted. He's asking, where does A/B testing comes into productionization of the ML? So I'll just quickly answer that A/B testing is a very important aspect of ML from the production point of view. There are a lot of write-ups over the internet where you can go in detail, but that's a very important part. The way it comes is very simple. Rather than you see, it's like this. Very simply, think of it like, rather than you making a decision which model is good or bad, because after a certain point of optimization, most of the models will be somewhere very close to each other in terms of accuracy. Then what you do at the end of the, again, when you focus on the consumer, just like the example that the Cast24 example that's such a share, imagine that you have 5 or 6 models which are sort of thrown in the public front end. Now, what we do from the A/B point of view is that we see which of the models are giving me higher engagement on my platform. And that is how you make a decision of which model is going to be part of my final production push. So this is how A/B testing is also sort of used. Very similar to how it is used in any other scenario.
Okay, so Lavi, I think one important question which I saw somebody asking, enterprise grade machine learning looks fancy, looks awkwardly complex, a lot of bounces over our heads, everything is good and fine, but how do small companies then start?
So what is happening for the small companies or mid-sized companies is the fact that there is a lot of maturity and innovation that are coming from the cloud vendors. So if you actually go to AWS, GCP, and Azure, they have simplified these things to a larger extent. There's a lot I can talk about it, but I want to sort of summarize this in a very single statement, saying that as soon as the things get complicated, think that they are also kind of a business opportunity for all the cloud players to come in between and sort of create their products which ease the whole effect. This is what we have seen in cloud. This is what we have seen in big data. This is what you're going to see in machine learning as well. So yes, it looks complicated as of now, but going 1 or 2 years down the line, and they have already started doing it. So if you just search for GCP MLOps, if you search for AWS MLOps, you will see that they already have products which will help you do things in a much easier way. So again, just Google SageMaker from AWS, you will get to see what I'm basically talking about.
Okay, so very nice. So friends, basically cloud players, what they're trying to do is they're trying to make your lives easier as a startup. I don't know how many of you know this, but you can do machine learning by writing a SQL query now. And that is the level of simplicity that these guys are bringing into your lives. So as days progress, you don't have to really break your head as to, okay, if I'm a startup, should I ever have existed in this place? Because it's so tough system out there. But the point is, that's where these cloud vendors are trying to solve the problem. They're making it very simple. Okay, they're making it so simple that if I were a startup, I just need to know which components in the cloud I will use, and they will only integrate it for me. They will only create they'll run auto machine learning on it. They'll build models out of it, and even possibly down the line, which I perceive is going to happen very soon, or it might have already happened. They'll deploy it for you and auto scale and auto descale for you. You don't have to do anything literally from those operations front. Okay. However, as you start growing in size, you can't rely on these cloud vendors. It'll be very expensive. So you want to kind of rely on something like MLAS. So as Rahul says, there's something called as MLAAS. What does that mean? ML, or machine learning as a service. You just deploy your models. I don't know if you guys have ever heard of Microsoft Azure. Microsoft Azure ML Studio. Just look at this. You create your machine learning, drag and drop. Okay, just create your machine learning, drag and drop. After that, you deploy it. It will automatically scale. As a startup, isn't this what you want? As a startup, you just work on the machine learning part. Rest, everything is their headache. They will make sure that the model is deployed for scalability. You have one customer today, they will work for one customer. You have 500 million customers tomorrow, they'll work for all 500 million customers tomorrow. Okay, but the point is, as you start scaling up as a company, you will find these things expensive slowly. So that is why people slowly want to get everything in-house. When you're a startup, you don't want to kind of break your head. Slowly, when you become bigger, you will want all of these things in-house. But the in-house component is actually very complicated, and you don't want to kind of do it always in-house. Okay. Now, could you give example for complex, normal, and easy use case of it? See, Anand, what is complex, normal, and easy is not about what is the degree of complexity of your model. As a startup, if you're handling 2 customers, it is the complexity that your servers are handling. The server is handling only 2 requests. If there are 500 million customers, the server is handling 500 million requests at the same time if they are all taking it right now. Okay, that is the complexity that I'm talking. It has nothing to do with the complexity of the model. You would have similar solutions for Google, for Amazon, for Azure. All of these players are chasing that golden goose. Okay. Now the question here is, Lavi, for the testing part, whose responsibility is testing?
Unfortunately, as of now, it is the data science responsibility, which is to say that there's no set team which are responsible for testing of the ML, because we don't have that as of now, and that's a new opportunity which is sort of coming up. But as of now, like I said, unfortunately, it's what a data scientist have to take care at this point.
Yeah, so currently data science as a field is not very mature. So that is why data scientists usually take care of most of these things. And think of it like you're writing something or you're building something. Who's the first person who's going to test it? If you're cooking some, I don't know, some palak paneer or something, who's the first person who's supposed to taste it before you give it to somebody else? It is you who has to test if your things are working properly or not. Okay. Why can't India have its own search engine chat? Why don't you start there? Okay, see, Jay, it's a very important question. It's a very nice question, but it's also a question that you have to understand from multiple angles. It's a very complex question, in fact. There's something called as government support. There's something called as flexibility of technological, I would say, knowledge. There's something called as affordability. There's something called as, will you be able to kind of execute at this scale? Okay, think of it. Aadhaar. Which country has an operation at that scale where it is trying to map every citizen? Apart from China, I don't see any other country which has this size of operation. So India does have few good things which China also has, or possibly even US. US is very small. US is 1/4 the population of India, Santosh. So the point is, Aadhaar, I'm talking of the scale of deployment. 1.3 billion people, roughly, I think 80% or 85% is already covered. Okay, so as you see, as things start becoming more and more complex, it's not just the company who's trying to build a search engine. Building a search engine may not be a big deal. But look at China's economy, it's called as closed economy. The government is allowing their people to thrive and they're enforcing people to use it. In India, tell me which government can enforce you not to use Google? Is it feasible? It's not feasible. So that is why Google is Google. However, in China, tell me which government allows people to use Baidu? Does the government allow people to use anything apart from Baidu? No, you cannot use anything apart from Baidu for searching in China. So there's an ecosystem that supports. Okay, so there's a lot of complex things that are out there, but what we would recommend is don't break your head on the big things. There are like too many things out there. Know what is the bigger picture, but start small. I don't know how many of you were there with us when Dr. Kirkborn had taken the session, but he said one very important statement. A lot of you oldies would remember. The newbies may not have seen that session, but the oldies would remember that he made this one very important statement. It is called as think big, but start small. Okay? Keep this in mind, friends. Make this as your to-go proverb, the proverb that you should keep with yourself in this space. Work it out, and we'll catch you successful in your lives. Thank you, guys. I think that's all for today. We have a session now. So thanks for participation. Thank you, Lavi, for the wonderful insights that you shared. And I hope people can make some part of it. But however, Lavi, once you are done with the finalization of the material, just let me know. We'll share it across.
Sure. Okay, thanks, everyone. Thanks a lot. Thanks, Uchit.
Thank you. Thank you, guys. You may all terminate your sessions now. We are done for the day. Thank you.